We will now go through the mechanism of drawing a plot using matplotlib. So we've talked about matplotlib PyPlot previously, and now we will go line by line on how to draw these two plots here. We will start with the first line, which is plt. So this plt is matplotlib PyPlot dot figure, and this figure takes this parameter, which in this case is fig size equals to 12,4. So PyPlot figure creates a new figure or activate an existing figure. It takes several parameters. In this case we're just using the fig size, we're not using the others. So you can have a unique identifier for the figure. You can have the fig size, which is what we are using here, and we are creating a figure that is 12 inches width and 4 inches of height. We could also set the DPI, so the resolution of the figure, in dots per inch, but we are using the default. We could set the background color, the border color. We could suppress the figure frame. We could clear, so if it is true and the figure already exists, then it's cleared. And we also have something called tight layout. So in this first line we are just using this plt.figure, and we are defining this figure, creating this figure with the fig size determined by this fig size here. Next we are calling plt.subplot, and then we are passing parameters 1, 2, 1. So plt.subplot add a subplot to the current figure. It's a wrapper of figure.addSubplot with a difference in behavior that will be explained in notes in case you need it. So it takes several parameters, and here is the documentation for this plt.subplot. We can call this function using different call signatures. So we could call as subplot with number of rows, number of columns, and the index, and some other keyword arguments. So I still didn't explain about keywords arguments in a function, but we will talk about this a bit later. So now we're just focusing here on plotting, and we see that we are using here in our example, we have the number of rows. So we have one row, which is here, and we have two columns, 1 and 2, and I will be working with the index 1. So this is the first and this is the second. So we can define the position of the subplot described by one of these three methods here. So we can use three integers, number of rows, number of columns, and index. So the subplot will take the index position on a grid with n rows and n columns. Index starts at 1 in the upper left corner and increases to the right. An index can also be a two tuple specifying the first and last indices. It could also be a 3-digit integer, so these digits are interpreted as if given separately. So I don't need to do it like this. I could remove the columns, the commas, and still it works the same. And you see here that I could set this to be the second and this to be the first, so they will swap here now. And this is exactly what is doing here. So we created a figure. Now we are adding an x to the current figure or retrieving an existing x. Next we have plt.title, and here is a string. So the only thing here in this string that we define a string using quotes, but what if we want to have a quote inside the string? So we're using this backslash here before the quote. So this will be part of the string. If we remove here, now we have a problem because the string finished here and then Python doesn't know what's happening. But if you include this backslash, so now it understands that, okay, this is part of the string, is not saying that the string is ending here. And we have this plt.title. plt.title will set a title for the axis. So it will set one of the 3 available axis titles. The available titles are positioned above the axis in the center, flush with the left edge and flushed with the right edge. We can also as parameter pass it a string, which is the text to use for the title, which is what we're doing here. But we could also change the font, so we could use a dictionary to control the appearance of the title. We can also change the location, so it could be center, left or right. We can also define a Y, so the vertical axis location for the title. 1 is at the top. If none, default Y is determined automatically to avoid decorators on the axis. We can also give some offset to the title and it will return the matplotlib text instance representing the title. This is exactly what we are doing here, and here we are displaying. Let's move back to the original position here. Now we have this figure. This figure will have 2 subplots. This is the subplot with index 1, and we are setting the title for this subplot 1. Next we do a bit more things, but it just repeats itself here. So now we are on the subplot with index 2, and then we will set the title for this subplot here. Now we have xlabel and ylabel. So the xlabel will set the label for the x-axis and the ylabel will set the label for the y-axis. So what we are doing here, we wanted to give a label to this axis here, and it will be the samples, and here will be an amplitude, the same for this one. So we are setting here the x label for samples, the y label for amplitude, and the same we do here. So it also takes parameters. So you have the label text, you have spacing points from the axis bounding box, including ticks and tick labels. So we also noticed that we didn't set these values here, it was automatically generated, and these are called ticks. So if we don't want to display like this, we can customize it. We will do this later on. Now we are starting with a basic plot, but you can change how it is displayed here, how it is displayed here. There are certain ways how to customize positions, text properties, and things like this. So we've done the title, the X and Y labels. Now it is the plot, and data was a numpy array, and plot we have here is the function that will indeed plot Y versus X as line and or markers. So there are 2 call signatures. We don't need to pass the data for the X. If we pass just one value, it will automatically consider values for X, and we'll just have the Y. This is what we are doing here, but we could plot the coordinates, give coordinates in terms of X and Y. We could do some basic color and marker and line style formatting. So we are using a default here, but let's change. We will plot data, and let's plot it in red. And well, this is a bit difficult to see, but let's do the same for this one here. So we have red, and now is some kind of dashed line. We could also change it. Now we have small red circles. So this is using this optional parameter FMT, which is a convenient way for defining basic formatting like color, marker, and line style. So it's a shortcut string notation that it will be described in the notes below here. So you can check the documentation and you'll see a lot of options on how you can give this formatting. We can also give labels to our data. We are not doing this now, but we could set some labels. We could plot different sets. But this we will check when we plot some more, let's call it less basic plots. Here it's just the first plot where you want to see this nice one cycle of a sine wave. Let's go back to the default values, and finally we have here this plt.grid, and it will configure the grid lines. So we can define it if it's true or false, whether to show grid lines or not. The grid lines will apply to major, minor, or both, and also we can set the line style, the color, the line width. So let's just try it out. Let's copy this. Let's put here in our grid. So now our grid is red with line width equals 2. Let's see if we can get a dashed line, and let's use thinner line. So we have dashed and thinner. It looks a bit nicer. So you can also configure the grid, and we will see more of this visualization configurations when we encounter more different plots. So this is, we cover all these lines here a bit, not going too deep, because there are a lot of things that we can configure. So depending if you want to change colors, change sizes, but we will go back to plots. But visualizing data is fundamental part in analyzing signals and systems, so we will have to come back to plotting many times. There are other plotting libraries that they are with different characteristics. We could have here, for example, some JavaScript based visualization tools that are wrapped in Python, and we could, for example, have zoom and change the sizes and pan and things like this. Matplotlib also offers such functions, but they are more or less limited when we are using an environment such as Google Colab. So that's it for plotting. But in this line here we have something special, not in terms of plotting, because there's nothing new here, but we have our NumPy array here, this data, and then we have 0 2 dots 110. So this is something that we didn't see it before, and it's the topic for our next tutorial to end with this code example number 2.